Today we're going to build an interesting and comprehensive project. It's going to be a side effects tracker for medical drugs in Python. So from the use case perspective, you're going to have a web interface. You can type in the name of a drug. You're going to get listed all the side effects that were recently reported in trials. And you're also going to get an automated message on Slack informing you about the new updates. On a technical level, it's going to be quite interesting and comprehensive because we have an MCP server. We're going to write this one from scratch that will communicate with an API to get the data. This MCP server will be used via a platform that makes everything secure and reliable. We're going to build a Flask application to do all of this. And as I said, we're going to have also a Slack integration. So you're going to learn a lot today. If you like this video, let me know by hitting a like button and subscribing. And now let us get right into it.
It's not a game, it's a rich thing.
Alright, so since this project is going to be quite comprehensive, we're going to approach it step by step. And the first step is to get the data about the side effects from somewhere. So we're going to use a public API. We don't need any authentication for this. I'm just going to use a publicly available API that's trustworthy, that gives us information about clinical trials and shows us the side effects of particular drugs. So the API that we're going to use today is clinicaltrials.government. This is an official API here. We can also take a look at the endpoints. In particular, we're interested in the studies endpoint, so we can click on this one here, and you can see it has a bunch of fields that we can pass here as parameters. In our case, we're going to be interested in the query.term, so let's say paracetamol here, and then we can also go down and set a page size. Let's go with 25, and we can also set a sorting criterion like results first, post date. That is going to sort by date, and then we can see what the response looks like. So I can click on try here to see what the object that I get looks like, and this one is quite comprehensive. So we're going to have to figure out where the information is. Of course, I already know that because I prepared the code for this video, but we have here the studies section, then we have the protocol section, and in this protocol section we have the information that tells us if there even are results for this study. Or actually, I think the information is even in a separate high-level field here called has results. So let me see if I can find it. There you go. So we have a field here, has results true. And then we also have fields, which I'm not going to now scroll through this because it's also a bit lagging. But the idea is we have certain fields, and I'm going to tell you exactly which ones they are. And you will also find the code for this project today in the description down below on my GitHub. But there are specific fields that tell us, on the one hand, does this trial have results? Then we can go to the section that tells us about the side effects. And then we also can go into this section, go to the serious side effects, and then just list the side effects that we have there. Now, to make sure that everything works before we proceed, let's build a simple proof of concept. For that, I'm going to create a new Python file here. Let's call it, or actually not main, let's call it test.py or testapi.py. And in here, we're going to just send a request, get a response, and try to get the information that we're interested in before we turn that into an MCP server. Now, for this to work, we need an external Python package called requests. Almost everyone has this already installed if you've ever installed anything. If not, just use pip or pip3 install requests. Or in my case, since I'm using UV here, I'm going to create a virtual environment. I'm going to say UV init and then UV add requests, which is the same as saying pip install. Now, this automatically creates some files. You can ignore those. We're just interested now in the test API, and we need the requests library. So we can start by saying import requests, and then we can define the base URL of the API, which is our clinical trials API. That URL is the following: https clinicaltrials.government/API/version2 or v2. Now we can also craft our parameters dictionary. This is going to contain the key value pairs that we saw before. So query.term, that's going to be the name of the drug. Let's go with paracetamol. And we're going to also pass page size, which is going to be 25. And we're going to sort again by the field called results first posted date or first post date. So that is the same thing that we submitted in the web API for testing. This is going to be what we sent here. Now we want to extract the information, which is the severe side effects. So to get a response, we can just say response is equal to requests.get, and we can send the base URL plus and then /studies. because that is already a specific endpoint. We're going to say here that the parameters are equal to the parameters. And then we can say the studies are response.json, and then in particular the studies object. So just to see if this works, we can run this. I will just go and say Python, or in my case, UV run, and then test API. In your case, you can say Python, and you can see we at least get the data, but it's in a very messy format. So as I said, we're not going to do the exploration here. I already know where the information is that we need, so I'm going to just provide you with the information. But of course, you can take this, explore this. You can also copy paste this into a language model and get an answer for what you're looking for if you want to do something different than me. But basically what we want to do is we want to aggregate the side effects. So if we find 5 studies and all of them tell me that a certain drug produces headaches, I don't want to have 5 times headaches. I want to have 1 time the symptom headache, and I want to have the aggregated probability. So how often does it occur? Because of this, I'm going to say aggregated is equal to an empty dictionary. And then I'm going to say for study in studies, iterate over the individual study objects. And there we're going to get the information. Does it have a result section? And in this result section, do we have reported side effects, severe side effects? And if yes, what are these? And the first key for that, as we already saw, is has results. So if study and then has results. If this field is true, then we can proceed. Otherwise, there's no reason to look into the study because we don't have any side effects. Then what we're interested in is, are there any serious events in the adverse event study? So we want to say the next filter is if, and then serious events, this is a string that has to be called like this, serious events in study results section, which is going to exist because we do have results. And in here we have an adverse events section. Adverse events, it's actually called module, not section. So if serious events in results section, adverse events module, then we do have serious events here. So in this case, I can say the events that we're interested in are, once more, study results section, then again, adverse events module, and in the end, serious events. And then we can print this just to see what this looks like, even though it's probably not going to be. Let's do a break after the first one. So let's run this and see what this section looks like. And you can see we get a bunch of stuff with ID, with the term, which is the symptom. And then we have also the number affected. So number affected, number at risk, and all that. And this is the information that we're going to now parse. So I'm going to say for event in events. And I want to do another check here because maybe there are certain events that don't have anyone at risk. So these are meaningless. They will always have zeros. So I want to make sure that the number at risk is not 0. So I'm going to say if event stats, first element here, and then num at risk, that has to be greater than 0. And then we can get the data. We can say that the name is the event term, and then the probability is going to be equal to event. Now we use stats again, 0, and then num affected. So how many people are actually affected divided by how many could be affected, number at risk. So event stats 0 and num at risk. So we don't have a division by 0 here. So all of this, of course, can be adjusted if you have a different use case, if you want to use additional fields, if you are looking for something else. Just look at the very large output object and get the information that you're interested in. I'm just going for a very simple example here. We get the symptom and we get the probability. And now we need to add all of this information to our aggregated dictionary. So if the name of this side effect already occurs in the dictionary, we need to just append the probability to the existing list. Otherwise, we need to initialize this key value pair. So I'm going to say if name in aggregated, then we're going to say just take aggregated. There's going to be a key value pair for the name, and there's going to be a list as the value. So I'm going to just append the probability. Otherwise, we're going to say if this is not part of the dictionary, we're going to say aggregated name is going to be a new list, and this new list will only contain the probability. Very simple and straightforward. Now, after the loop, we need to craft a results list. So this is going to be a list of dictionaries. That's going to be a dictionary comprehension, basically, or a list comprehension actually with dictionaries. So we're going to say for name and probabilities in aggregated.items. So the name is going to be the name, the probabilities is going to be the list. And here now we're going to craft the object side effect name is going to be name. And then side effect probability is going to be the sum of the probabilities divided by the length of the probabilities. So just the average probability that we have here. All right, so that is a basic way to do that. The only thing I want to do now is I don't want to return anything below a certain threshold. So if there are side effects with very small probability, I'm just not going to list them. You can, of course, adjust this if you want to have every little side effect. You maybe just want to filter for 0. But now what I'm going to do is I'm just going to return x for x in results. If then x, the probability, the side effect probability is at least greater than 0.01. I'm expecting more than 1%. And of course, I don't return because I don't have a function yet. We're going to have this as a function later on. For now, we can just print. So let's run this and see if we already get what we're expecting here. What I get here is side effect name, infusion reaction, side effect probability, side effect name, COVID-19, side effect probability, and so on and so forth. So we do get quite a few side effects. The only thing that I realized now is that I'm not doing this on a correct level because, of course, we're iterating over studies and I get all the side effects for the studies. So I want to craft the results list and do the aggregation 3 levels or 4 levels to the left. So at the very left after the loop, we want to do the for loop. And once everything is aggregated or collected, we want to do the aggregation and print the output. So maybe that has to be indented. Let's run this again and see if that works. So let me save this and rerun the command that we just ran. And now we get one aggregated side effects list, which starts here. So we have side effect name, side effect probability. This is the list of side effects. And this, of course, can now be used to beautifully visualize this or send a Slack message or something like this. That is the functionality. So this is the proof of concept. Now we need to turn that into an MCP server. And for the entire MCP and tool use setup, we're going to use arcade.dev. So arcade.dev is sponsoring this video today. And what we're going to do here is we're going to create an MCP server using their Arcade MCP tool. Then we're going to deploy the MCP server on Arcade. We're going to also have a Slack tool which works through Arcade. And we're going to use that in our Flask application that also will use a LangChain agent that is powered by the OpenAI API. That is the goal of this video today. This is the structure that we're going to pursue here. And what Arcade does is it makes everything easy. It handles all the authentication for us. It's for a secure, efficient workflow when it comes to MCP and tool use for agents. So what we're going to do is we're going to clear the command line, and you're either going to say pip or pip3 install, or as I said, in my case, uv add, and then we're going to type arcade-mcp. This is a Python package, so we can just easily install this. And once this is installed, we can go and say arcade new, and then let's say side effects or side_effects MCP. This now creates a new server project. This is the side effects MCP. We have a source directory and we have server in here. So this already comes with some code, but we're not going to need that. I'm just going to get rid of all this. We're going to maybe keep one of these tools for knowing how to use or for already having the proper annotation here. But basically the idea is quite simple. It creates this project. It uses sys for argument parsing mainly. So we can remove these comments and keep the main section as is. But the interesting thing that happens here is defining the MCP app and also the tool. So we're going to just define our API call here, our processing as a tool, and then we're going to easily deploy this to arcade.dev. So for this, let me get rid of the stuff that we're not going to use here. I'm not going to use context or Reddit. I'm just using the MCP app here. What I am going to use, however, and for this, I should open up the command line. I will use the requests module. So I'm going to go to the side effects MCP, and I'm going to say uv add request in here as well, because we do have a PyProject toml here. So that is going to add it as a dependency. And now we can also say import requests. And all we need to do now is we need to adjust this tool to work differently. First of all, we're going to call it get side effects for drug. Then I'm going to say drug name is the parameter here, annotated string, and then the name of the medical drug to find side effects for. And this is going to not return a string, it's going to return a list of dictionaries. That is our tool signature. And in here now, we're just going to copy paste the code. So we're going to take all this. This is how it works. all of this stays the same. I'm going to paste this code here into the tool. Again, if you want to just copy paste this yourself, you can go to my GitHub and copy the code. So now we have still base URL params. We just need to make sure that everything is passed properly, because now we have drug name here. So we need to get rid of paracetamol and just say drug name as a parameter here. The rest should stay the same. And of course, now we can return instead of print, and that should be it. So this is going to be our tool for getting the side effects for a given drug. Now, the only thing that's missing here is, of course, a doc string, which is always useful for MCP. So I'm going to say here, get side effect reports from clinicaltrials.gov for a given drug name. That is going to be the description of the tool. And now what we're going to do with this MCP server is we're going to easily deploy it to Arcade. So I'm going to clear the command line again. I'm going to go into this side effect directory here, and I'm going to say Arcade deploy, then -e, and then source side effects MCP server py. And as you can see, it starts the deployment process now. It found one tool, and now you can see deployment successful, server is running. So of course, the first time you run this, you will have to authenticate yourself. That is going to be a quite simple process. And now we can go back to Arcade, and in the dashboard now, you should find in the server section that you have a deployed server. So when you go to servers, you should find now side effects MCP, Arcade hosted, running. And if you click on tools, you should be able to see that there is this tool, get side effects for drug. We're going to come back to this later on, but now let us start by building the Flask application, which is going to use this tool via an MCP gateway that we're going to set up here. And we're also going to use Slack via a tool provided by this tool catalog here in Arcade. But first of all, let's set the infrastructure by building our Flask project. So for this, I'm going to close these two files. I'm going to close the MCP folder here. I'm going to create a new directory, which I'm going to call agent app. And in this agent app here, I'm going to also, maybe for the sake of keeping this separate, I'm going to go back. I'm going to go into the agent app, and I'm going to say UV init again. This should now create a PyProject Tomo here, and we're going to say UV add Flask SQL Alchemy. And of course, again, you can do pip install if you're using the core pip. Then I'm going to say LangChain, or actually I'm going to say LangChain OpenAI. And of course, my camera was blocking this, so I moved it to the upper right corner. And then also LangChain -MCP adapters to be able to easily use the MCP tools. And finally, in order to get the API keys, we're going to say python.env as well. And what you now also need in this agent directory is a file called .env. In this file, we're going to have API keys. One of them is going to be the OpenAI API key to power our LangChain agent. And we also need the Arcade API key. So the OpenAI API key is something that you probably know how to get. For Arcade, we're going to go to arcade.dev again into the dashboard. And then down here, you can easily see get API key. So you can create an API key, copy it. I'm not going to do it because I already have one that I'm going to use here. But you also need to specify another field here, which is the Arcade user ID. And that is just going to be the email that you're using for your specific account. So in my case here, it's accounts@neural9. So accounts@neural9.com, and the rest is going to be your OpenAI API key and your Arcade API key that you can get from here. I'm not going to show this section because I'm going to now enter my keys and close the file. All right, so back to our Flask application. We have a main py file, but first of all, before we go into the application or into the agent, we're going to create a database model. So this is not just going to be for querying the information once and that's it. We're going to keep track of side effects over time. We're going to update the database, and if there's something new, we're going to inform the user via Slack. So I'm going to say here, new file models.py, actually not in the venv, but here. So new file models.py. And here we're going to say from SQL or Flask SQL Alchemy. And here I'm going to say from Flask SQL Alchemy import SQL Alchemy. So that's going to be our object relational mapper that we're going to use to transform Python classes into database tables. So I'm going to say db is equal to SQL Alchemy, and then we can define our database models. So the first one is going to be the drug itself. So that's going to be db model. A drug will have an ID. That's going to be a column of type integer. And that's also going to be the primary key of this table. And then we also want to have a drug name. So the string value. That's going to be db column db string, let's say 100 characters, and it's not nullable. So we have to provide it. Then we're going to have a second class for side effect reports. So it's going to be side effect reports. That's also going to be db model. It's also going to have an ID, so we can copy it like this. And then to make this faster, I'm going to copy paste here the other two fields: side effect name, side effect probability, just a string, and a float, both not nullable. Now, of course, we need to connect it to, so we're going to have a foreign key relationship that a drug can have multiple side effect reports, and a side effect report belongs to a single drug. So actually, we're going to say down here that we have the drug ID. That's going to be a db column of type integer, and it's going to be a db foreign key for the field drug.id, and of course, nullable false. It cannot exist on its own. Now, we also want to have a back reference here. We want to have an attribute in the drug class that allows us to get all the side effects. So here I'm going to say side effects relationship is equal to db relationship side effect reports, or actually, since this has to be not plural but just report. And then I'm going to say back reference is going to be drug and lazy is equal to true. So that is our db model. This is what our agent will fill. Now, in order to make our agent work, we need to create an MCP gateway on Arcade Dev. This is going to allow us to use our tools. For this, I'm going to go to MCP gateways and then create MCP gateway. Here, I'm going to type side effects MCP. I already have one here that I used for testing. We can leave all of this empty, but we're going to have to provide two things. On the one hand, the authentication method is going to be via headers. So we're going to authenticate ourselves via the API key, and we're going to select tools. So I'm going to select tools here, and I'm going to go to the tools section, and I'm going to type site. And you can see here we have get side effects for drug. This is a tool I can select. So I'm going to click on this. And in addition to that, we also said we want to use Slack. So I'm going to type Slack. And we're going to, in particular, need send message, who am I, and I think it also doesn't hurt if we do get user info, get conversation, metadata, just so we can find the different channels. And then we're going to just say use 5 tools. And finally, we're going to say create MCP gateway. So now we have this MCP gateway, and we can just copy this URL. That is going to be the thing that our AI agent will use to get access to the tools. So let's go back into our VS Code environment. Here I'm going to create now a new file in agent app called agent.py. And the very first thing is I'm going to say gateway URL is going to be equal to this here. Above that, let us now do some imports. We're going to import OS. We're going to also import async.io. These are core Python packages. Likewise, from datetime, import date. And now we're going to import the LangChain stuff. So from LangChain, import create, or was it LangChain.agents, import create agent. From LangChain.tools, import the tool decorator. And then from LangChain MCP adapters, .client, import multi-server MCP client. Then the third level of imports is, of course, we need the models that we just created. So from models, import drug and side effect report. These are what we're going to need. And then we're going to say the Flask application is going to be none. The reason we do that is because we're going to import agent in main, and we don't want to import main and agent because then you have circular imports. To resolve that, we're going to set this to none. In main, we're going to set this to the application, and that is needed to provide context. So we're going to define tools here. I'm going to start by saying tool and then list drugs. That is just going to give us a list of all the drugs. So that's going to return a list of strings, and a doc string is going to be list all drugs in the database. And here now we're going to need the context. So with Flask app dot app context, we're going to get the drug. So I'm going to say drug dot drug name for drug in drug dot query all. So that's going to return all the drug names in the database. Now, in addition to this tool, we're also going to add 3 more CRUD tools. So these are just creating stuff in the database, getting stuff from the database, nothing fancy. So I'm going to copy paste them. As I said, the code is in the description down below. You can easily also do this by copy pasting, but I don't want to spend like 20 minutes here typing just functions that are CRUD. All we're doing here is always providing the context, and then in the case of create drug, we create the drug, we check if it exists before. That's basically it. Here we create the side effect, same idea as before, and then here we list the side effects given a certain drug name. Now, the only thing I noticed is I forgot to import the DB object here, and also I think we're not going to use date. This was from an older version where I tried to do something with a date. But essentially, we have now these 4 static tools. These are not related to the MCP tools. These are just for listing drugs, creating side effects, and listing side effects for a given drug. Now, in addition to this, we also need to have the tools for communicating with Slack and the tool for communicating or for getting the data from the API. So these are just for the local DB changes, but we still need the tools from the MCP server. And for that here, we're going to define a function called getMCPTools. So async def get MCP tools. And here we're going to create our multi-server MCP client with a dictionary object where we have arcade as a key pointing to another dictionary. And we say the transport is going to be HTTP, obviously, because it's hosted on Arcade. The URL for this MCP server is going to be the gateway URL that we defined at the very top. This one here for the MCP gateway. And then here we need now the authentication. Headers is going to point to a dictionary, and the dictionary is going to have 2 things, the API key and our user ID. So authorization is going to be a Bera token, an F string. So it's going to be Bera, and then it's going to be OS getenv arcade API key, and then a special field which is going to be called arcade-user-id, and that's going to be os getenv arcade user ID. And of course we need to load these in the main file, but that is going to be the client that we initialize here, and then we can just say return await client dot get tools. So that's going to be one thing. We're going to get tools from here, and then we can also define a list, local tools, that are going to be our DB tools that we have. So what was it? List drugs, list side effects, create drug, and create side effect. All right, then that's almost it. The main file is missing still. So here we need to create our Flask application. From Flask, import Flask and render template. Also request and JSONify. Then also import async IO. And of course, for our API key, we need to say from .env import load.env. And then finally, we need to import from agent import local tools and get MCP tools. Then we can load our environment variables. We can create a Flask application by saying __name __. We have to say that the config for SQL Alchemy is going to be a SQLite database. So SQL Alchemy database URI is going to be equal to SQLite, then 3/ drugs.db. That is that. Now we can say db init app, and now we can also set, and I think for this we need to import this as well, from models import db. And now we can also set in the agent file, and for this actually we should import agent itself, import agent. So maybe something like this. Agent.flask app is going to be equal to app. And now we're almost there. We need to say with app.app context, we're going to say db create all to actually create the tables. Then we're going to say MCP tools is equal to async IO dot run. And we're going to run the MCP tools or get MCP tools function here. And then we're going to say all tools is equal to local tools plus MCP tools. And now we get to the magic of it all, which is the agent. We're going to say agent is equal to create. Actually, I saw that I did the import in the wrong file. So we actually don't need the create agent here. We also don't need async IO here. We're going to use create agent in main py, which is here. So LangChain agent, create agent. We're going to now say create agent. The model that I'm going to use is OpenAI GPT 4.1. We're going to provide all tools as a tool list here, and then a system prompt. So system prompt is equal to, and I'm going to make this a multi-line string because we will have to include some context. All right, so that is the system prompt. You are a helpful assistant for finding side effects of drugs. When using Slack, always send messages to the channel allneural9. If you ever find new information that was not already in the DB, send a Slack message that informs the user about the update. So the procedure should always be list all drugs in a database. If the drug already exists, list all side effects for that drug. Get the new side effects from the internet. If there is any new side effect that is not in a database, create a new side effect report for that drug in a database. Send a Slack message to the user with the new information exclusively. You can, of course, refine this, make this better. And one thing also, if you're setting the Slack tool up for the first time, you will have to authenticate with Slack. So you have to give it permission to work as you, which I already did. So this already works on my Slack account. But that is the system prompt now. And the last thing that we need to do is we need to define two endpoints. Then we're going to just add HTML, CSS around it. That's not going to be the real issue here. So I'm going to start by saying app.routes. That's going to be /home. Or actually, let's just call this / and call the function home. And here we're just going to say drugs is equal to drug query all. And for this, of course, we need to also import drug and side effect report here. Maybe we're going to need this later. And then we're going to say return render template. The template is going to be index.html and drugs is going to be drugs. So the whole rendering will be done by iteration in the HTML file that we're going to provide here in a second. And then I also want to have an app route /query. And this has to be a post request here. So methods equals post. That's going to be the query endpoint. And the query will be whatever the user provides, like give me side effects for paracetamol, for example. So user query is going to be equal to requests.json get and then query. And the magic happens when we actually invoke the agent. So we're going to say result is equal to async io.run agent.ainvoke. And here we're going to pass a dictionary. Messages is the user query. And the response is going to be whatever the result is, the messages of that, the last entry, and the content of that. And to get it in a proper format, we're going to say return JSONify response is response. Very last thing in this file, if name equals main, we're going to run the application. Debug mode is going to be true for testing purposes. And now the very last thing that we need to do is we need to create a templates directory. And in this templates directory, I'm going to create a file called index.html. And this one is definitely going to be copy paste because I'm not going to spend time here writing CSS, JavaScript, and HTML. Very simple. We just list the drug side effects here. We iterate over the database objects, nothing fancy here. And we send a request to the query API. That's basically it. Nothing crazy. So I'm pretty sure we probably have to do some bug fixing because almost never does everything work the first try. But let's go and now run main.py. Okay, so this is what the application looks like. Let's try to get the side effects of paracetamol. And of course, I don't have Slack opened up right now, so maybe we should retry this here in a second with Slack actually running side by side. But let's see if we get anything here in the first place or if we get some bugs that we need to fix. Okay, so I saw one of the problems in my HTML. I was using the correct term here. I used the wrong field name, so it is side effect reports actually, not side effects relationships. So side effect reports is the key that we're interested in. So now I deleted the database and I'm running this again. Let's try now. Give me the side effects of paracetamol. And there you go. We have the side effects reported here. Actually, in my HTML template, I had the date as well. You can add this if you want to, but you can see we have the name, we have the probability. And the one thing that I didn't show yet is the Slack message. So here now I open Slack side by side. You can see that I got actually a message here at 4:13. Right now it's 4:14. So that was actually right now. Now give me the side effects of aspirin. Let's see if this works. This would basically do the exact same thing again and send us a message. And there you go. I get the message before I even get the results in my application. New side effects for aspirin has been added to the database. And down here now I get the reports. So yeah, this is a basic example of a side effects tracker. To recap the architecture, what did we actually do? we have an agent that uses an MCP server. This was the first thing that we did. We had an MCP server. This MCP server communicates with the clinical trials API. And what we do here is we pass a drug name. We go through all the studies, aggregate the probabilities. Of course, you can do that in a weighted way. So you don't just take the average, but you take the average, but with weights. Makes much more sense. This is a very simple example here. But we get the side effects and we return it to the user. That is an MCP server written with Arcade MCP. We easily deployed this to Arcade in the dashboard. So it's running here in servers, side effects MCP. And then we created an MCP gateway that used the Slack tools and also our MCP tool here. We then use this gateway URL for our agent as a gateway URL. We define some static tools here, some local tools, and we connect it to the MCP tools. Now our agent is able to work with the database and also with the MCP tools provided via Arcade. And then we just had a Flask application with a UI around it that allows us to now get information about certain drugs. And if there's anything new, we're going to get a Slack message as well. So that's it for this video today. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. Also, don't forget to check out Arcade, the sponsor of this video today. The link is in the description down below, and you would be helping out the channel if you check them out. Besides that, don't forget to subscribe and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.